Welcome to our deep dive into text preprocessing, a fundamental step in the world of text mining. Before we can extract meaningful insights from text data, we need to prepare it properly. Text preprocessing transforms raw, unstructured text into a clean and structured format, making it ready for analysis. This process is crucial because real-world text is often messy, filled with inconsistencies, errors, and irrelevant information. By the end of this video, you'll understand why preprocessing is essential and how it sets the stage for successful text mining projects. Let's start by exploring what text preprocessing actually involves and why it's the backbone of any text mining workflow. Text mining is the process of deriving valuable information from large volumes of text data. It involves techniques from statistics, linguistics, and machine learning to uncover patterns, trends, and relationships hidden within text. However, before any analysis can begin, the text must be cleaned and standardized. This is where text preprocessing comes in, acting as the bridge between raw data and actionable insights. Understanding the role of preprocessing helps us appreciate its importance in the overall text mining pipeline. Raw text data is rarely perfect. It often contains typos, inconsistent formatting, slang, abbreviations, and even irrelevant content like advertisements or HTML tags. These issues can significantly hinder analysis, leading to inaccurate or misleading results. That's why preprocessing is so important. It helps us clean up the data, remove noise, and ensure that our analysis is based on high-quality input. By addressing these challenges early, we set ourselves up for more reliable and meaningful text mining outcomes. Text preprocessing pipeline is a series of steps designed to clean and standardize text data. Each step addresses a specific issue, such as removing unwanted characters or converting all text to lowercase. The pipeline ensures that the data is consistent and ready for further analysis. While the exact steps may vary depending on the project, the overall goal remains the same: to transform messy, unstructured text into a format that computers can easily understand and analyze. One of the simplest yet most effective preprocessing steps is converting all text to lowercase. This helps eliminate inconsistencies caused by different capitalization styles. For example, apple and apple would be treated as the same word after lowercasing. This step is crucial for ensuring that our analysis doesn't mistakenly treat words with different cases as separate entities. It's a small change that can have a big impact on the quality of our result. Punctuation marks can add noise to text data, especially when we're interested in analyzing the actual words. Removing punctuation helps simplify the text and makes it easier to tokenize or split into individual words. This step is particularly important for tasks like word frequency analysis, where punctuation can otherwise skew the results. By stripping out unnecessary symbols, we focus our analysis on the core content of the text. Tokenization is the process of splitting text into smaller units, usually words or sentences. This step is foundational for most text mining tasks, as it allows us to analyze each word or sentence individually. Tokenization makes it possible to count word frequencies, identify patterns, and perform more advanced analyses. It's a crucial step that transforms raw text into manageable pieces for further processing. Stop words are common words like the, is, and in that don't carry much meaning in most analyses. Removing these words helps reduce noise and allows us to focus on the more meaningful terms in the text. This step is especially important for tasks like topic modeling or keyword extraction, where we want to highlight the most significant words. By filtering out stop words, we make our analysis more efficient and insightful. Stemming and lemmatization are techniques used to reduce words to their root forms. Stemming chops off word endings, while lemmatization uses linguistic rules to find the base form. For example, running, runs, and ran would all be reduced to run. This helps group similar words together, making our analysis more consistent and meaningful. Choosing between stemming and lemmatization depends on the specific needs of your project. Numbers can sometimes add unnecessary complexity to text data, especially if they're not relevant to the analysis. Removing numbers helps simplify the text and ensures that our results aren't skewed by irrelevant numerical values. However, in some cases, numbers may carry important information, so it's important to consider the context before applying this step. When appropriate, removing numbers can make our analysis cleaner and more focused. Extra spaces, tabs, and line breaks can clutter text data and make it harder to process. Removing unnecessary whitespace helps standardize the text and ensures that our analysis isn't affected by formatting issues. This step is quick and easy, but it plays an important role in producing clean, uniform data that's ready for further processing. Special characters like hashtags, emojis, or symbols can introduce noise into text data. Depending on your analysis goals, you may want to remove these characters or replace them with standardized tokens. Handling special characters appropriately ensures that your data is clean and that your analysis isn't thrown off by unexpected symbols. Misspelled words are common in raw text data, especially in user-generated content. Spelling correction helps standardize the text and ensures that similar words are grouped together. This step can be automated using dictionaries or machine learning models. By correcting spelling errors, we improve the accuracy and reliability of our text mining results. Text normalization involves converting text to a standard format, such as replacing contractions with their full forms or standardizing abbreviations. This step helps ensure that similar words are treated the same way during analysis. Normalization is especially important when working with informal or user-generated text, where variations in spelling and grammar are common. In working with web data, HTML tags can clutter the text and interfere with analysis. Removing these tags helps clean up the data and ensures that only the actual content is analyzed. This step is essential for projects involving web scraping or online reviews where HTML formatting is common. URLs often appear in online text data, but they rarely add value to most analyses. Removing URLs helps declutter the text and ensures that our analysis isn't distracted by irrelevant links. This step is particularly useful for social media or web-based projects where URLs are common. Emojis are increasingly common in digital communication. Depending on your analysis goals, you may want to remove emojis, replace them with descriptive words, or analyze them separately. Properly handling emojis ensures that your text data is consistent and that your analysis captures all relevant information. Text data may include accented characters, especially in multilingual datasets. Standardizing or removing accents helps ensure that words are treated consistently, regardless of their original form. This step is important for projects involving international or diverse text sources. Contractions like don't or can't are common in informal text. Expanding these contractions to their full forms, such as do not or cannot, helps standardize the text and ensures that similar phrases are treated the same way during analysis. This step is especially useful for natural language processing tasks. Slang and abbreviations can make text data difficult to analyze. Replacing these with their standard forms helps ensure that the text is consistent and that our analysis captures the intended meaning. This step is particularly important for social media or user-generated content, where informal language is common. Duplicate text can skew analysis results and lead to misleading conclusions. Removing duplicates ensures that each piece of text is only analyzed once, providing a more accurate representation of the data. This step is especially important for large datasets or web-scraped content where duplicates are common. Case sensitivity can cause similar words to be treated as different entities. By standardizing case, usually by converting all text to lowercase, we ensure that our analysis is consistent and that word counts are accurate. This step is simple but essential for reliable text mining results. Negations like not or never can change the meaning of a sentence. Properly handling negations ensures that our analysis captures the true sentiment or intent of the text. This may involve combining negation words with the terms they modify or using specialized algorithms to detect and process negations. In informal text, users often repeat characters for emphasis like "so good." Standardizing these repetitions helps ensure that words are treated consistently and that our analysis isn't skewed by exaggerated spelling. This step is particularly useful for social media or chat data. If your dataset includes multiple languages, it's important to identify and handle non-English text appropriately. This may involve translating text, filtering out certain languages, or applying language-specific preprocessing steps. Properly managing multilingual data ensures that your analysis is accurate and relevant. Named entities like people, organizations, or locations can carry important information. Identifying and standardizing these entities helps ensure that our analysis captures key details and relationships within the text. This step is essential for tasks like information extraction or knowledge graph construction. Dates and times can appear in many formats within text data. Standardizing these formats or extracting them as structured data helps ensure that temporal information is accurately captured and analyzed. This step is particularly important for time series analysis or event detection. Text data may include currency symbols or measurement units. Standardizing or removing these elements helps ensure that numerical values are interpreted correctly during analysis. This step is important for financial or scientific text mining projects. In social media data, hashtags and mentions can provide valuable context or metadata. Depending on your analysis goals, you may want to extract, remove, or analyze these elements separately. Properly handling hashtags and mentions ensures that your analysis captures all relevant information. Quotation marks can indicate direct speech or quoted content. Depending on your analysis, you may want to preserve, remove, or process quoted text differently. Handling quotation marks appropriately ensures that your analysis accurately reflects the structure and meaning of the text. Parentheses and brackets can contain additional information or clarifications. Deciding whether to keep or remove this content depends on your analysis goals. Properly handling these elements ensures that your text data is clean and that important information isn't lost. Hyphens and dashes can connect words or indicate breaks in thought. Standardizing or removing these elements helps ensure that words are tokenized correctly and that our analysis isn't affected by inconsistent punctuation. This step is important for accurate word segmentation. Ellipses or sequences of dots can indicate pauses or omitted content. Deciding how to handle ellipses depends on your analysis goals. Removing or standardizing ellipses helps ensure that your text data is consistent and that your analysis isn't disrupted by unusual punctuation. Bullet points and lists are common in structured text such as reports or presentations. Standardizing or removing list markers helps ensure that the content is analyzed as intended. This step is important for projects involving structured or semi-structured text data. Section headers can provide valuable context or structure within text data. Deciding whether to keep, remove, or process headers separately depends on your analysis goals. Properly handling section headers ensures that your analysis captures the full structure and meaning of the text. Text data may include references to tables or figures. Deciding how to handle these elements depends on your analysis goals. You may choose to extract, remove, or annotate these references to ensure that your analysis is focused and accurate. Footnotes and endnotes can provide additional information or citations. Deciding whether to keep or remove these elements depends on your analysis needs. Properly handling footnotes ensures that your text data is clean and that important context isn't lost. Academic or technical text often includes references and citations. Removing or standardizing these elements helps ensure that your analysis focuses on the main content. This step is important for projects involving scholarly or scientific text data. Page numbers can appear throughout text data, especially in scanned documents or PDFs. Removing these numbers helps clean up the text and ensures that your analysis isn't affected by irrelevant numerical data. Headers and footers can add noise to text data, especially in documents with repeated content on each page. Removing these elements helps ensure that your analysis focuses on the actual content and isn't skewed by repetitive information. Optical character recognition (OCR) can introduce errors when converting scanned documents to text. Correcting these errors is essential for ensuring that your analysis is based on accurate data. This step may involve manual review or automated correction tools. Handwritten text can be challenging to process, especially if it's digitized using OCR. Preprocessing handwritten text may involve additional steps such as manual transcription or specialized recognition algorithms to ensure that the data is accurate and usable. Some text data may be accompanied by images, audio, or video. Deciding how to handle these multimodal elements depends on your analysis goals. You may choose to extract text from images, transcribe audio, or integrate multiple data types for a richer analysis. Text data can be structured like tables or unstructured like free-form text. Preprocessing steps may differ depending on the type of data. Understanding the structure of your text helps you choose the right preprocessing techniques for your analysis. Covered a comprehensive range of text preprocessing steps, each designed to clean, standardize, and prepare text data for mining. Remember, the specific steps you choose will depend on your data and analysis goals. Always start with a clear understanding of your dataset, and don't hesitate to customize your preprocessing pipeline as needed. By investing time in thorough preprocessing, you lay the foundation for accurate, insightful, and impactful text mining results. Thanks for joining us on this journey through text preprocessing.